Hello COP 1000 students, this is Dennis. I just wanted to review the least amount of change assignment. This program will generate about 10 random numbers. In other words, this number can be whatever you want it to be. And these random numbers, though, have to be between 1 and 99 because it's change for $1. So change is going to be between a penny and 99 cents. The program will then show the least amount of change possible to give back. You can assume coins include half dollars, quarters, dimes, nickels, and pennies. So there's your change. To do this program, the first thing you're going to need is you don't really need this constant times to repeat, but it makes your code more generic. So if I change this number to anything I want, that's how many loops I'm going to do or generate change. I have another constant for lower bound and upper bound. Actually, this violates my rule as far as constants go. This should be in all uppercase letters. I want to change that. Okay, so times to repeat is now a constant, just like lower bound and upper bound. This is used for the random number generator. This returns the lowest number of 1 and the highest number of 99 and all numbers in between. To generate a random number, we have to do something called seed it to the system clock, and we have to do that at least once, and that's what's going on right here. My variables are going to be a loop control variable, a variable to generate the amount of change, and I'm going to call that money. And as I manipulate this money, I'm going to keep track of the remainder. Then I'm going to keep track of how many half dollars I have, quarters, dimes, nickels, and pennies. Here's that loop, and I'm going to loop times to repeat times, but this is now a constant. So in this program, I'm going to start at 0 and loop up to whatever this is. So if I had this as 10, I'm going to do this 10 times. This is my formula for generating a random number between lower bound and upper bound. And lower bound was 1, upper bound was 99. This is going to generate random numbers between 1 and 99 and store it here in this variable called money. Now this is where my calculations are going to take place. The very first calculation is halves. I'm going to take that money right here and mod it by 50. If I mod that by 50 and this number is 50 or higher, this is going to return the remainder and stick it over here in remainder. So for example, if this was 99 cents, it would return 49. This is going to take the money and divide it by 50. Remember, integer division chops off the remainder. So the most there can be is a single half, and this is going to account for that. Then I'm going to do the same thing for quarters, dimes, and nickels. So I'm going to take the remainder now and divide it by 25, then mod it. And this is going to tell me how many quarters I have, and this is going to continue bringing the change or the remainder down. Do that again for dimes. Bring the remainder down. Nickels. Notice after nickels, when I do this mod or whatever's left, it's going to be just my pennies, and there you have it. So after I do my calculations, the next thing is to output some stuff. And to output some stuff is nothing more than a bunch of printf statements. So I print out the total change, and then I do a test so that this line does not print 0. It only prints if there were halves. So if I had a half dollar, this would say it. If I had quarters, this would say it. If I didn't, this would not say quarters. Same thing for dimes, nickels, and pennies. Just to be cute on pennies, if there's more than 1, I put the S. If there's exactly 1, I put a Y. That's pretty much it. Pretty simple little program. And there are many more ways to do it than I just showed you. Many more ways than I. So here's a program in summary. I do my includes. I like a pause sometimes in my code, so I always do that. Here's my comments and my documentation. Here is setting up the loop control variable and my upper and lower bound, seeding the random number to the clock, my variable declarations. So I have a loop control variable, keep track of my money and my remainder, my halves, my quarters, my dimes, my nickels, and pennies. I go into a loop. I repeat that loop, in this case, 10 times. If I change this to 50, this would be 50 times. Inside of the loop, each time I regenerate the amount of change between lower bound and upper bound. So this is going to be between 1 and 99. I start to calculate my quarter, or my halves, my quarters, my dimes, and nickels. Here I am. Here's my quarters. Here's my dimes. Here's my nickels. Once I'm done, and my pennies. Once I'm done, I just start outputting things, and there is my output to the screen, and then my program ends. And that's it. Actually, that's not it. The end is end of my loop and then end of main. So my loop goes from here to here, and then after I'm done looping number times to repeat, I end my program. Let's run it real quick so you can see it run. So the first time it generates the number 56, 1/2, 1 nickel, that's 55, plus a penny is 56. Second number is 29. 29 is 1/4, 4 pennies, 29. The third number is exactly 50, which is 1/2 and nothing else. Here's 43, that's a quarter, a dime, and a nickel, that's 40, plus 3 pennies. 18 is a dime, a nickel, and 3 pennies. 34 cents is a quarter and a nickel, that's 30, plus 4 is 34, and so on, and so on, and so on. That's it. Good luck.